Hello, welcome to HawkMath. Today we're going to be proving the following identity. This is the limit as n goes to infinity of 1 plus a over n to the power bn plus c, and this is equal to e to the power ab. Now, this identity comes up a lot in every area of math, but specifically in competition math. And if you notice in this identity, the c actually doesn't matter. It just becomes e to the power a times b. So let's get into proving this. To start, let's set this expression equal to y and try to solve for y. Now, we see an n in both the base and the exponent, so let's try taking the natural log of both sides to simplify this. Now, as you can see, we can use the natural log properties to bring this exponent in front of the natural log. This gives us the limit as n goes to infinity of bn plus c times the natural log of 1 plus a over n. We can now use the distributive property to separate this limit into two different ones. One with c times the natural log of 1 plus a over n, and one with b times the natural log of 1 plus a over n. Looking at this second limit, we notice that as n goes to infinity, we have c times the natural log of 1, which just becomes 0, so this goes away. We are now left with the limit as n goes to infinity of bn times the natural log of 1 plus a over n. Now as n goes to infinity, this becomes 0 times infinity, which is indeterminate. Therefore, we need to use L'Hopital's. In order to do this, we can move this n in the front to become a 1 divided by n in the denominator. Let me slide this over here to make more room. Now we can take the derivative of the numerator and denominator to use L'Hopital's rule to end up with this expression right here. Now notice the negative 1 over n squared on the denominator will cancel with the negative 1 over n squared on the numerator that came out of chain rule. This will give us the limit as n goes to infinity of ab divided by the quantity 1 plus a over n. Now as n goes to infinity, this denominator just becomes 1, so we have the natural log of y equals ab. Finally, taking e to the power both sides, we arrive with y equals e to the power ab. Now that we are done proving this identity, I'm going to go through a few different forms that look very similar to this but are slightly different and also appear in contest math. We can arrive at the first by taking the substitution x equals 1 divided by n. Now as n goes to infinity, x will go to 0, and the insides become 1 plus ax to the power b divided by x plus c. Now, this common form also shows up often, and again, you can notice that the c doesn't really matter. Now I want to go over two quick practice problems to make sure you guys have the identity down. The first one is a limit as n goes to infinity of 1 plus 2 divided by n to the power 3n. This will just become e to the power 2 times 3, which equals e to the 6th. The second problem I want to look at is a limit as n goes to infinity of 1 minus 3 divided by 7n to the power 4/5 n. We have to be careful here because the negative sign is included in the coefficient. So we have e to the power negative 3/7 times 4/5. And this is equal to e to the negative 12 over 35. Thank you for watching. I really hope you enjoyed the video. Please like this and subscribe if you want to see more.